In today's video, we're going to use the binomial probability table to answer a few questions about the binomial random variable. Then we'll talk about characteristics of binomial random variables. There are many different binomial probability tables, and the way to figure out which table you need to use is determined by your n value in the problem. So in this table, we can see that the n value is worth 25. So if we look at problem number 3, you can see it says, if x is a binomial random variable, use table 2 in Appendix A to find the following probabilities. And it tells us right here in the problem that n equals 25. So that's how we know to use this particular table. Also given in the problem, we need to know what the probability is. That's our p-value. P is equal to 0.7. So in our table, all across the top of the table are various probabilities. So we want to use the column for 0.7. I'll just indicate that. Correct column. The other detail that we need to know is we are looking for the probability that x is less than 10. In other words, which values of x are less than 10. It's important to note that 10 is not included here because we do not have the equal sign included, only numbers that are smaller than 10. So we're looking along the rows on the side. First find row 10. Now that we have row 10 and column with probability of 0.7, we can go back and look at which probability are we going to calculate. And that is the probability that x is less than 10. So in order to be less than 10, that must be the values from 0 through 9 and including 9. So it's not going to include 10. So we're going to use the column 0.7 and the rows 0 through 9. So to write that, we have the probability of x less than 10 is the same as finding the probability of x less or equal to 9. Now this is a cumulative table, so that means the value that we find for less or equal to 9 is going to be including every value below 9 and including 9. So we're looking for the probability of x less or equal to 9 actually because of the table being cumulative sums. So here's the cutoff. Cumulative sum of 0.000 is the probability of x less or equal to 9. That 0 comes from adding all of the previous values together. Our second question, using the same table, now we are looking for the probability that x is less or equal to 10. So notice the equal is given, that means we are including 10 and every value below 10. So now we're looking at 0.002. So that is essentially adding all the rows from 0 through 10, and we write that as probability of x less or equal to 10, and we just take the number that's already there in the box. Our third question is asking for the probability of x greater than 10. Again, the equal is not included, so the values greater than 10 are actually 11, 12, 13, and upwards. So we want to think of this in terms of the complement of 10. So we're thinking of 1 minus some probability. So the complement of greater than 10 would be less or equal to 10. So we're using 1 minus the probability of x less or equal to 10. The probability of less or equal to 10 is 0.002. And so we actually are using 1 minus 0.002 to give us the final answer of 0.998. In the next question, we're looking for the probability of x greater or equal to 10. When we see greater than, that's kind of a clue that we are thinking about complements. We're going to take 1 minus the probability that x is less or equal to 9, because those would be the complementary values. So again, we have our table for n of 25. Our column is the 0.7 probability, and 1 minus the probability that x is less or equal to 9. Find where the row and the column meet. So we would have 1 minus 0 gives us 1. Now think about that for a minute. If we're looking for the probability that x is greater or equal to 10, and everything below 10 is 0, does it make sense that 1, the probability of 1, remember, represents 100% of the data, would fall above that value? So maybe that will help you to understand that question a little better. Finally, for part E, the probability that x is exactly equal to 10. That means we are not including numbers less than 10. We are not including numbers larger than 10. We only want values exactly equal to 10. So the entries in the table are cumulative probabilities. So remember to subtract all values below the one you want to find. First, find the value of the probability of less or equal to 10, and then subtract all the values below that. That would be the probability of x less or equal to 9. So in the table, probability of x less or equal to 10 is our 0.002, and we would subtract the probability of x less or equal to 9. That would be 0. So we have 0.002 minus 0 is equal to 0.002. And that is our final answer. In problem number 4, it says, where will you get your next pet? So we have a short scenario here and a few questions to answer about it. According to a poll, half of all pet owners would get their next dog or cat from a shelter. Consider a random sample of 15 pet owners and define X as the number of pet owners who would acquire their next dog or cat from a shelter. Assume that X is a binomial random variable. So our first question is, for this experiment, define a success. So success is an owner acquiring his or her next pet, or dog or cat specifically, from a shelter. So looking back in the narrative, it says, according to a poll, half of all pet owners would get their next dog or cat from a shelter. And it says to define X as the number of pet owners who would acquire their next dog or cat from a shelter. So that reveals what a success would be for this experiment. Part B, for this binomial experiment, what is N? So we're wondering how many people were involved in this poll. It says, according to the poll, half of all pet owners would get their next pet from a shelter. Consider a random sample of 15 pet owners. So those 15 pet owners is our value for N. So N is equal to 15. And finally, for this binomial experiment, what is P? Remember, P represents the probability of success. So we are looking for our probability of success. It says half of all pet owners would get their next dog or cat from a shelter. So the word half represents 50% or 0.5 probability. So what we need to now gather from this information is, if N is equal to 15, then we need to use the binomial table associated with N value of 15, and then we'll use the column 0.5 for probability to answer any other questions. Here's the probability table, and you can see right at the top that our N value is 15, and we'll be looking at probability of 0.5. So I've just written that again here in the problem. So the column 0.5 is our probability. And now the first question we're looking at for part D. We want the probability that x is exactly 6. So find row 6 just as your first reference using probability of 0.5. But remember, 0.304 represents probability of 6 and everything smaller. So we would start with the probability less or equal to 6 and then subtract the probability below. So that's the probability of x less or equal to 5. So in our problem, we're setting it up as the probability of x less or equal to 6, subtract the probability of x less or equal to 5. So we have our 0.304, subtract 0.151, and our final answer is 0.153. And you'll notice that is a smaller number than 0.304 because we are subtracting all the probabilities that fall below that value. Part E, we're looking for the probability that x is greater or equal to 8. So we will find row 8. And just as a reference, we're starting with 0.696. Now, if we are looking for greater or equal to 8, remember, greater means we're thinking complement. So we want 1 minus everything that's falling below 8. So we're starting with 1 minus the probability of x less or equal to 7. So our probability of x equal to 7, we're going to subtract 0.5. So 1 minus 0.5 gives us 0.5. And last, we're looking for the probability that x is greater than 10. So 10 is going to be a new row for us. So our reference value, 0.941. And again, we're looking for the x values greater than 10. Because it's greater, I'm automatically thinking 1 minus something that's falling below. So 1 minus the probability that x is less or equal to 10. So we need to include equal because equal was not included in the original probability. So we are taking 1 minus the probability of x values less or equal to 10. That's 0.941. So the result is 0.059.